Hello everyone. Welcome to Department of Collegiate and Technical Education. The subject is Machine Tool Technology for 4th semester Mechanical Engineering. Myself is Prasanna, lecturer in Mechanical Engineering, Government Polytechnic, Mulbagal. Today we are going to discuss the second chapter, that is the lathe and operations, which contains 11 sessions. The marks weightage is 30 marks and total weightage in the question paper is 21%. What are the contents we are going to discuss today is the lathe, the operations of the lathe, the parts of lathe, the specification of center lathe and multi-choice questions. The chapter 2, that is the lathe and operation. Session 1. Introduction of the lathe machines. See, actually the lathe is the mother of the cutting tools and the machine tools, in which it removes the metal from a piece of a wire to the required shape and size. Lathe is one of the most important machine tools in the metalworking industry. A lathe operates on the principle of a rotating workpiece and a fixed cutting tool. The cutting tool is fed into the workpiece, which rotates above its own axis, causing the workpiece to be formed to the desired shape. The functions of the lathe. Lathe, it is used to remove the excess material in the form of chips by rotating the workpiece against a stationary cutting tool. Industrial revolution demanded more production, more precision. Changes in manufacturing process lead to the development of the high speed and special purpose lathes. These are the industrial demands. The center lathe or the engine lathe. The lathe machine is also known as a center lathe because it has two centers between which the job can be held and rotated. The main parts of the center lathe are bed, headstock, tailstock, carriage, etc. You can see in the figure, okay, very important. This is the headstock and this is the tailstock and this is the tool post. The tool post is been gradually linearly moved in the feed rod as well as the gear rod. It has been provided, and this is the bed in the tailstock assembly. This is the tailstock assembly, and here in the headstock we have the spindle with the chuck. These are the chucks for holding purpose. This is the live center and this is the dead center, and this is the tool post, compound rest, cross slide. Again we have the spindle speed selector, headstock assembly. Again we have the feed selector, chuck, chip rock, and we have the apron and the split nut, long nut, and it can be moved in this direction. Here the cutting tool will be placed. That cutting tool, it may be a single point cutting tool or a multi-point cutting tool. It can be moved in either direction or like this or either direction like this, and this tool post can be swiveled to 45 degree or 60 degree or 90 degree. This is very important of the tool post, that is the center lathe or the engine lathe. Lathes are the oldest machine tools, and its components has been derived. The bed, it supports all the major components which is made up of cast iron. The carriage, it slides along the ways and consists of the cross slide, tool post, apron. Headstocks holds the jaw for the workpiece, supplies power to the jaws and has various drive speeds as we seen in the figure. The tailstocks, it supports the other end of the workpiece. The feed rod and the lead screw, it is powered by a set of gears from the headstock. Very important of the engine components. Next we go for the working principle. Yes, see, this is, you can observe, this is the material which has been kept in the headstock center and the tailstock center, and the work material will be here, the tool will be here. Okay, as soon as the tool will be held in the tool post, headstock which contains of the chucks, tailstock which is having the center, and this is the work. As soon as the single point cutting tool is fed into the workpiece, so that what happens in the perpendicular direction, the material will be chipped, the workpiece will be chipped. Okay, you can see in the rotation of the work here. Here what happens, again the cylindrical, that is a turning operation here. Okay, this is the turning operation. Here the tool has been fed so that it forms the cylindrical surface. Okay, if the tool moves parallel to the workpiece, cylindrical surface is formed. If the tool is fed into parallel, so that a cylindrical surface has been formed. That is the working principle of the lathe. Okay, next we go for the inclined purpose. See, for the inclination purpose, for the taper purpose, what happens, this is the workpiece has been kept and this is the chuck. Here the tool post, the entire compound mandrel of the tool post, it has been swiveled to a certain angle like 45 degree, so that the tool will be come in contact with the workpiece at an angle of 45 degree, so that it forms the bevel or a taper shape. If the tool moves inclined to the axis, it produces a taper surface and it is called as a taper turning. Very important. You can see here we have the half of the taper angle, and this is the half of the taper angle. It has been swiveled the compound rest of the tool post. This is the working principle of the lathe. It holds the work between two supports and called centers. Chuck or faceplate is also used for holding the work. It is mounted on the machine spindle. Is held and supported on a tool post. The movement of the job is rotation about the spindle axis. The tool is fed against the revolving work. The movement of the tool is either parallel to or at any inclination to the work axis. That is the working principle of the lathes. Next we go to the specifications of the lathe. The size of the lathe is generally specified by the following means: swing or maximum diameter that can be rotated over the bedways, maximum length of the job that can be held between the headstock and the tailstock centers, bed length which may include headstock length also, maximum diameter of the bar that can pass through the spindle or collect the chuck or capstan lathe. And you can see in the figure, this is the length of the bed. Capital A is the length of the bed. Capital B is the distance between the centers. That is the live center and the dead center, distance between the center. And capital C is the diameter of the work that can be turned over the ways. And capital D is diameter of the work that can be turned over the cross slide. A is length of the bed, B is the distance between the live center and dead center. Capital C is diameter of the work that can be turned over the ways. Capital D is diameter of the work that can be turned over the cross slide. These are the specifications of the lathe. Specifications of the lathe. Number 1 is maximum swing over bed. Number 2, maximum swing over carriage. Number 3, height of centers over the bed. Number 4, maximum distance between the centers. Number 5, length of the bed. Number 6, width of the bed. Number 7, Morse taper of center. Number 8, diameter of the hole through spindle. Number 9, faceplate diameter. Number 10, size of the tool post. Number 11, number of spindle speeds. Number 12, lead screw diameter and the number of threads per centimeter. Number 13, size of electrical motor. Number 14, pitch range of metric and inch threads, etc. Okay, before moving to the multi-choice questions, in this sessions we came across what is a lathe and what are the parts and the components of a lathe as well as specifications of the lathe. Multi-choice question: which machine tool is known as the mother machine tool? Option A drilling, option 2 milling, option C lathe, option D none of the mentioned. As earlier said earlier in the class, the option is C, that is the lathe is the tool is known as mother of the machine tool. We go for the second question. Which type of the surface is produced by turning the operations in lathe machine? Option A flat, option B cylindrical, option C taper, option D none of the mentioned. Yes, we can obtain all the three, and the answer is very wrong. All of the mentioned. The answer is all of the mentioned. Right? Okay, we go for the second question. The lathe is primarily used for producing dash surfaces: flat surfaces, curved surfaces, taper surfaces. The option is none of the mentioned. Okay. Fourth one, what is the necessary condition for turning? Option A, material of workpiece should be harder than the cutting tool. Material tool should be harder than the material of the workpiece. Hardness of the cutting tool and material of the piece should be same. None of the mentioned. Answer is cutting tool should be harder than the material of the workpiece. Transverse of the tool parallel to the axis of the job is termed as a cross feed, a longitudinal feed, both cross feed and transversing feed. None of the mentioned. Option B is longitudinal feed. Okay, these are the options. Answers. Thank you. We'll meet in the next sessions.